Gotcha. Thank you. Can we get started? Yeah. So what did we see in the previous class? Biot-Savart law. Then we saw the Biot-Savart law in the vector form, right? Now what we'll do is we'll see the first application of Biot-Savart law, which is going to be in this. Okay, make a note of this topic. So the topic we are going to see is magnetic field due to a state current carrying conductor of finite length, right? So this is one of the applications of Biot-Savart law. Here, what I'm going to do is we will consider a conductor of finite length, right? A state current carrying conductor of finite length. And let me call this conductor as XY. And due to this conductor, we will calculate the magnetic field at a point P, which is at a distance A from it. So whenever I say distance from a point to a state current carrying conductor or a straight line, it is always the perpendicular distance. Okay. And in this scenario, let's say that the current I is flowing in the upward direction. So all that we need to do is we need to calculate the magnetic field due to this whole conductor XY. But here the question that we need to answer is, we know that according to Biot-Savart law, the value of magnetic field is calculated not due to the whole conductor, rather it is calculated due to a small current carrying element, right? So the first thing that I'm going to do is I'll consider a small current carrying element of thickness dl at a distance L from this point. Because we considered from this point only we took P, no? So from here vertically at a distance L, I'll consider a small current carrying element of thickness dl, and let me label this point as O. So what are all the parameters that we need to define the magnetic field due to this current carrying element? One is I need its thickness, because the formula is ideal sine theta divided by 4 pi r square. So mu naught ideal sine theta divided by 4 pi r square. So I is known, dl we have assumed, right? We need sine theta and the distance from this current carrying element to the point P. So for us to get sine theta, what I will do is from here, I will take this distance to be r. I'll take this distance to be r and this angle to be theta. Clear? So if that is the case, then the magnetic field due to this current carrying element dl, I can write it as dB is equal to mu naught times ideal sine theta the whole divided by 4 pi r square. Right? So the logic is very clear now. Whenever you have dB from which you need to extract d, all that you need to do is integrate. So I need to integrate this function, right? For me to get the magnetic field due to the whole conductor, for which if I define the limits and do a proper integration, I'll get the answer, right? So those who are online are able to hear me?
Yes, sir.
Okay. Yeah. So I can get the answer for the total magnetic field. But there is a challenge here. Thing is, I cannot integrate this function because this dB is not a function of one variable here. It is a function of multiple variables. Let me explain what it means. So here dB depends on many parameters which are mentioned here, out of which let's see which are constants and which are variables. Mu naught is a constant. I is a constant. It's a steady state current. DL is not a constant because DL is the thickness of the element that I have assumed, which can vary from person to person. So DL is not a constant. Sin theta, depending on where I considered this DL, from this DL, what did you do? You drew a line which is joining this point P, no? Right? So this angle theta will change according to the location where you took that DL to be. Meaning L is deciding what should be the value of theta. So how many variables have already come into picture? DL is a variable, theta is a variable. Hence, since theta is a variable, sin theta will also be a variable. Next question is, depending on where you take this DL, the distance from this DL to this point P will also keep varying. So R is also a variable. Hence, here my job is to convert this whole thing into a function of one variable and then proceed. Okay. So first, let me explain what we are supposed to do. Listen to this carefully. If I ask you, what is the derivative of sin theta? What will the answer be? The answer will be cos theta, but this is wrong. Because you should ask me a question of, you're differentiating that sin theta with respect to what? Had the question been d by d theta of sin theta, then the answer is cos theta. Had it been d by dx of sin theta, the answer would have not been cos theta, it would have been cos theta into d theta by dx. So you need to do chain rule. So who is playing an important role here? It is not the direct derivative of sin theta, rather with respect to whom you are differentiating it. So that is why the denominator is a very, very, very important thing to be questioned. Right? Having said this, in a similar way, if you observe, if I ask you what is integral of sin x, the answer, if you write it as minus cos x and leave, you're wrong. Because you didn't put a main question of, you're integrating sin x with respect to whom? So integral of sin x, you need to have this differential coefficient dx in picture for you to write it as minus cos x. So the meaning of it is, whenever you're doing integration or differentiation, the differential coefficient d of something plays an important role. Now the point is, why am I mentioning it here? Because if I look at the expression which I'm supposed to integrate, I have dl. In the place of dx, I have dl. But if you observe, the other two variables have no relation to L. I don't know what is the relation between sin theta and L. I don't know what is the relation between R and L. So you're able to understand. So what we are supposed to do is, even before we start integrating it, the first thing that we need to do is convert it as a function of one variable. That one variable, you can choose anything. You can either completely make it as a variable of L so that you will have dl, or you can completely make it as a function of theta so that you have d theta, or you can completely make it as a function of R so that you have dr. So these are the three variables that are possible in this case. For that, what I'm going to do is, I'll use a little bit of mathematics here. First thing, I took this to be theta, right? I will consider another angle phi in the same triangle. So that when I draw the right angle triangle, let me call this as M for instance. If I draw the right angle triangle MOP, this will be phi and this will be theta, so that this is L, this is A, and this is R. Makes sense? Question is, in this triangle itself, who is a variable and who is a constant is what we need to see. L is a variable because we introduced it. R is a variable because depending on where that M point is going to be, R will change. Since L and R are variable, theta and phi are also variable. But the only constant you have in this triangle is A. Because A is the distance from the conductor to the point where you are calculating the field. Since the distance is perpendicular distance, irrespective of wherever on this conductor you take that point O to B, the distance from that O to P will always be a constant. So A is a constant, except A in this triangle, every other parameter is a variable. Is that point getting registered? Okay. Now I'll go step by step. Listen to this carefully. Okay. Listen to this. It's a slightly tricky derivation. Concentrate. So if this is theta, this is phi. What is the relation between theta and phi? If I take this to be 90, theta plus 90 plus phi is equal to 180 degrees. Theta plus 90 plus phi is going to be 180, which implies theta will be equal to 90 minus phi. Okay, let me call this as, so let me call this expression as first expression. Let me call this as 2. So all the extra work that I'm doing is to substitute back in the equation number 1. Is this registered? So theta is equal to 90 minus phi. Second, I will frame a relation between, since I have a right angle triangle and I have a trigonometric variable here, that is giving me an idea saying that I can think of a relation between a variable and a constant in terms of trigonometric values. So L is one variable, R is one variable. So these are the two variable distances. They can have individual relation with A. In the sense, if I take L divided by A, then I get L by A is equal to tan phi. L by A is tan phi, opposite by adjacent, which implies L is equal to A tan phi. Right. What did I tell you? I am doing all these manipulations only to take them and substitute it in equation number 1. So you should not leave the connection with equation number 1. Observe, in equation number 1, I don't need L directly, rather I need DL. So here, since I got L, for me to get DL, I need to differentiate. So when I differentiate on both the sides with respect to phi, what do I get? A times derivative of tan phi is going to be secant square phi. So DL will be equal to A times secant square phi d phi. So DL, which I need to substitute here, I got a value, which I'll call it as equation number 2. Sorry, equation number 3. Right? So DL is equal to A secant square phi d phi, 3, which can be substituted back in 1. Now, what else do I need? I need the value of R. So R is a variable, A is a constant. I'll frame a relation between them. A by R is equal to adjacent by hypotenuse is equal to cos phi, which implies A is equal to, sorry, which implies R is equal to A divided by cos phi. So 1 by cos phi will become secant phi. So which will become A times secant phi, which I will call it as 4, because all I need is R. So having this expression in mind, I converted everything in terms of one variable. Now you see what I did is, if I substitute the value of theta here, since I wrote theta in terms of phi, this will get converted in terms of Sin theta will get converted in terms of phi. DL, I already converted in terms of phi and d phi. R, I converted in terms of phi. So I made this whole expression of 3 variables into 1 variable phi. Now I can integrate with respect to that phi. So before we integrate, we need to know how to take the limits. So I'll explain that. Before that, you can make a note of it. Those who are online, I hope you're able to understand.
Understood, sir.
Sir.
So if you observe, all that we need to do is take 2, 3, and 4 and substitute it in 1. Right. So what is the first equation? dB is equal to mu naught ideal sine theta the whole divided by 4 pi r square. The second equation is theta is equal to 90 minus 5. The third equation is dl is equal to a secant square phi d phi. And the fourth one is r is equal to a secant phi. So take these 3 and plug it here. right? That is what we need to do. So dB will be equal to how much? Mu naught I, leave it as it is. In the place of dl, you will write it as a secant square phi d phi. And in the place of theta, you will write it as 90 minus phi, the whole divided by 4 pi into, in the place of r, you will write it as a secant phi. And since it is r square, it is a secant phi the whole square. Right. So this will be equal to mu naught I a secant square phi into sine of 90 minus phi is going to be equal to cos phi, the whole divided by 4 pi into a square secant square phi. 4 pi. Yeah. The whole thing multiplied with d phi. So I brought this d phi outside because this is going to be a function and I'm integrating with respect to the variable phi. Okay. So secant square phi is gone. A will cancel this once. So you will have dB is equal to mu naught I into cos phi divided by 4 pi a times d phi. So if you observe, there is only one variable and you can integrate with respect to that one variable. Now the question is, I need to take its limits. So for that, if you observe, from here, if I join to the topmost point, I'll take this angle to be phi 1. Similarly, from the horizontal surface, if I join it to the bottom of this conductor, I will take this angle to be phi 2. Since phi 1 is going in the clockwise direction, we will take this phi 1 as positive. And since phi 2 is going in the anti-clockwise direction, you will take this phi 2 to be negative. So basically, I'm taking one to be positive and other to be negative. Okay. So the value of phi, where is it varying from? Since you are integrating with respect to phi, where is the value of phi varying from? It is varying from phi 2 to phi 1, but phi 2 is negative, phi 1 is positive. So having said this, what we can do is, from this I can write b is equal to integral of mu naught I times cos phi, the whole divided by 4 pi into a times d phi, where the limit varies from negative of phi 2, because phi 2 is going in the downward direction till the end, and phi 1 is going to be positive value at the topmost end. Is that clear? So whatever is a constant can be taken out of the integral. When you take that, you get mu naught I divided by 4 pi a into integral of cos phi d phi between where? Minus phi 2 to phi 1. So what you are supposed to do is, b will be equal to, I'm taking the continuation from there, b is equal to mu naught I divided by 4 pi a, the whole multiplied with integral of cos phi is going to be negative of sin phi, and it is varying from minus phi 2 to phi 1. Okay. So this will be equal to, if I take the negative sign, okay, I'll leave the negative inside itself. I'm sorry. There is a correction. Yeah. So integral of cos phi is going to be sin phi. So integral of cos phi is sin phi from minus phi 2 to phi 1. This will be equal to mu naught I divided by 4 pi a, the whole multiplied with Bring that phi 1 inside. It become sine phi 1 minus, you take the minus phi 2 inside, it become minus sine of minus phi 2. So sine of minus phi 2 is minus sine phi 2. So minus of minus will become plus. So the answer will be mu naught I divided by 4 pi a into sine phi 1 plus sine phi 2. So this is going to be the value of magnetic field due to a straight current carrying conductor of finite length. So sine phi 1 plus sine phi 2, and this expression is expected to be remembered. Okay, you need to remember this. So now I can make a note of it. Done. Yeah. Now, we will see some special cases with respect to the straight current carrying conductor itself. So the first point is, if the current carrying conductor is considered to be infinitely long. So whenever they use the word long wire, right, by default, you need to assume that it is an infinitely long wire. Okay. And there is a point P, which is at the symmetric center of the system. So the point P is neither taken at the top nor at the bottom. It is taken in such a way it is somewhere at the center. Right. And what is going to be the value of phi1 and phi2 so that we'll be able to calculate the value of magnetic field. So if you observe, B is equal to mu naught I divided by 4 pi A into sine phi1 plus sine phi2. Right. Now, if you observe from point P, right, from point P, if I keep drawing lines, I'll draw a line in such a way that, see, this point should go and meet the topmost point. Only then I'll be able to define the angle phi1. Phi1 is basically the angle defined between this horizontal and the line joining the point P to the topmost point. So, if this is growing infinitely long, right, what will happen to this line which is joining from point P? This will also keep increasing its angle. So, it will keep increasing its angle. At one point, what will happen? It will become perpendicular. Right. So, what will happen? The angle will keep increasing like this. And at one point, it will become perpendicular. So, the value of phi1 is going to be pi by 2. Similarly, what will happen to phi2? Phi2 will also keep increasing in this direction, and at one point it will become pi by 2 with a minus sign. Yeah. But here a point to be noted is, since in the derivation itself we already used a minus sign, don't use a minus again. So just take that pi by 2 and substitute it. So B will be equal to mu naught I divided by 4 pi A into sine pi by 2 is 1 plus another 1. It is going to be 2. So what will you get? You will get 2 times mu naught I divided by 4 pi A. This and this will get cancelled. This will be equal to mu naught I divided by 2 pi A. So the magnetic field due to an infinitely long conductor and where the point P is lying at the middle of the conductor is mu naught I divided by 2 pi A, and this is a very, very, very important expression. This is a very, very, very important expression to be remembered. Is that clear? Make a note of it. Shall I proceed?
1 minute, sir.
Yeah. So the next case is, if the conductor is infinitely long, but the point P lies near the end. So again, the conductor is of infinite length, but this time, where is the point considered to be? One of the ends itself is considered to be, okay, correction. one of the ends itself is considered to be coinciding with the point P, right? So if you observe, the point P is taken in such a way that if I try to join from here to the infinite end, then how will the angle phi1 be? The angle phi1 will be 90. So phi1 is going to be 90 or pi by 2. Then what about phi2? Phi2 will be 0. So phi2 will be 0. Okay. Now the question is, B is equal to mu naught I divided by 4 pi A into sine phi1 plus sine phi2. Same thing again substituted. So it is going to be mu naught I divided by 4 pi A into sine of phi1 is how much? 90, which is going to be 1. What is sine of phi2? It's going to be a 0. So answer will be mu naught I divided by 4 pi A. So this is an other important expression to be remembered. So if you observe the difference between the previous one and this one, the value is half here. Sorry, the value is half there. The value is double here. Okay. Done. So the third condition is, if the conductor is of finite length L and the point P lies on its perpendicular bisector, then what we can say is phi1 and phi2 will be equal to phi. See, if the conductor is of finite length, if I take a point P here, which is on the perpendicular bisector, right? Then from here, if I join, and from here, if I join, what is this angle going to be? This will be phi, and this will also be phi, because first thing, it's a perpendicular bisector. And second thing is, since the distances are equal, it forms an isosceles triangle. Am I right? No. The length of the conductor, if you take to be L, the length of the conductor is taken to be L. This length will be L by 2, and this length will be L by 2. Right. Now, what is the value of B? It is equal to mu naught I divided by 4 pi A, where A is again going to be the perpendicular distance. Mu naught I by 4 pi A into sine phi1 plus sine phi2. Right. So this will be mu naught I divided by 4 pi A into, what is the value of sine phi1? Sine phi1 and sine phi2 in this case is going to be the same. So sine phi1 plus sine phi2, I can actually write it as 2 times sine phi. Now, what is the value of sine phi from this triangle? If this length is L by 2, this distance is A, then the hypotenuse is going to be root of A square plus L square by 4. is root of a square plus L square by 4. So this will be 2 times, what is sine phi? Opposite by hypotenuse, root of a square plus L square by 4. So 2 and 2 will get cancelled, right? So you're left out with mu naught I divided by 4 pi a into L divided by root of a square plus L square by 4. Okay. So this will be the expression if the conductor is of finite length and the point P lies on the perpendicular bisector of it. Done. Okay. So with those values, let's solve some problems that are based on magnetic field due to a straight current carrying conductor. Okay. So the first problem is a current of 10 ampere is flowing east to west in a long wire. So when you see the word long wire, you need to get this infinitely long wire in your mind. Okay. It is kept horizontally in the east-west direction. Find the magnetic field in a horizontal plane at a distance of 10 centimeter north, 20 centimeters south from the wire. I repeat, 10 centimeter north, 20 centimeter south from the wire, and in the vertical plane at a distance of 40 centimeter downward and 50 centimeter upward. Before we solve, first let's visualize this. So we know that if you take the directions, it is going to be north, south, and this is going to be east, and this is going to be west. Right. Now the point is, here they mentioned that it is kept horizontally. So one thing that you can visualize is if I keep the compass like this, north, south, you can take this to be east and west. That is one way of considering. This is going to be in the vertical plane. This is the meaning of vertical plane. So horizontal plane means this wire itself is lying on this plane like this. So that I am north, this side is north. On the table itself, this is north, this is south, this is east, and this is west. Okay. And in which direction is the current flowing? The current is flowing from east to west direction. So when the current is flowing from east to west direction, we need to find the magnetic field in the horizontal plane at a distance of 10 centimeter north. So with respect to this conductor, where will 10 centimeter north be? It will be this side at a distance of 10 centimeter. So if I take this to be the horizontal table, there is a conductor lying like this, where this is going to be east and this is going to be west, and the current is flowing in this direction. The north is present on the table itself, and it is at a distance of 10 centimeter. So it is at a distance of 10 centimeter. Now, since this is an infinitely long wire and this point is considered to be at the center, what formula are we supposed to use? We'll use B is equal to mu naught I divided by 2 pi into A. So it will be mu naught I divided by 2 pi A. Remember, mu naught divided by 4 pi is 10 power minus 7. So if I multiply with 2 on both the sides, I get mu naught divided by 2 pi is equal to 2 into 10 power minus 7. So this mu naught divided by 2 pi is going to be 2 into 10 power minus 7. So it is 2 into 10 power minus 7 into what is the value of I? It is 10 ampere. The whole divided by what is going to be the value of A? The distance is 10 centimeters. So 10 into 10 power minus 2. This 10 and this 10 will get cancelled. So you'll be left out with 2 into 10 power minus 5 Tesla. Okay, this is with respect to the magnitude. Right. What about the direction? Observe, if this is how the plane is, this is east, west, and this is north. So you apply right hand thumb rule. You place the thumb in the direction from east to west and curl the fingers as if you are going to hold it. Right hand. Right hand. So curl the fingers as if you are going to hold it. When you do this, here the paper, sorry, here the fingers are going and touching the paper. So wherever it is touching the paper, it is going to be into the plane. So at this north point, it will be into the plane. So into the plane with respect to this horizontal is vertically downwards. Are you able to understand? So it is going to be 2 into 10 power minus 5 Tesla vertically downward. So this is east to west. Place the thumb of your right hand from east to west. Curl the fingers. So it is hitting the plane here. This is the place where north is present. So at the north, it is hitting. So it is going to be into the plane. So into the plane means where are my fingers going? Downwards. So they are going downwards vertically. That is why I wrote it as vertically downward. Is that clear? Concentrate பண்றேன் எழுதிட்டு இருந்தேன் சொல்லும்போது பார்த்தேன் இந்த பாரு என்னால next time I'll not repeat சரியா. So this is the direction of current. If you place the thumb like this, curl the fingers. When you're curling, it is going and hitting the paper here. So wherever your fingers are going and hitting the paper, that is treated as into the plane. So another, since your fingers are going downwards here, it will be vertically downwards. So one side, if you find whether it is vertically downwards or vertically upward, the other side will be exactly opposite to it. Is that point clear? Okay, listen. So if I take the south direction here, right? If I take the south point to be here, the south point is considered to be 20 centimeter, right? So we need to find 20 centimeter southward from the wire. So if I take this to be B1, B2 is going to be equal to how much? It will be the same mu naught I divided by 2 pi A. So mu naught by 2 pi is still going to be 2 into 10 power minus 7 into I is 10, the whole divided by, what is the value of A? 20 into 10 power minus 2. So this will cancel this 2 times, 2 and 2 are gone. So you will get the answer as 10 power minus 5 Tesla. Now it is easy. Since in the northward direction, the magnetic field was vertically downward, exactly on the opposite side, it will be vertically upward. It will be vertically upward. Am I clear with this? Okay. Now, next point is, we need to take the vertical plane into consideration. And in the vertical plane, if you see, there are 2 points. One point is 40 centimeter downward, and the other point is 50 centimeter upward. Okay. So for this, if you observe, the plane is still like this. This is the horizontal plane. And this is going to be east, west, and the current is flowing in this direction of magnitude 10 ampere. So if this is how the plane is, right, and this is where the conductor is lying, there is a point which is 40 centimeter vertically downward. There is a point 40 centimeter considered below the table. If you assume the table is the horizontal plane, below the table, there is a point which is at a distance of 40 centimeter from it. If I take this point to be P1, for instance, then magnetic field at point P1 is going to be how much? It will be mu naught I divided by 2 pi A, and mu naught by 2 pi can still be written as 2 into 10 power minus 7 into I is written as I is 10 divided by, what is the value of A? It is going to be 40 into 10 power minus 2. This will cancel this 4 times. Here it's gone 2 times. So 1 by 2 is going to be 0.5 into 10 power minus 5 Tesla. So it will be 0.5 into 10 power minus 5 Tesla. But listen to this. If I take, okay, listen. If I take this to be the direction of current, right? So I keep the thumb in this way. And when I curl my fingers at the bottom, what is the direction of magnetic field? It is coming towards you. Right? Remember, on the horizontal plane, this is east, this is west, this is south, and this is north. So in which direction are your fingers coming out? It's coming in the southward direction. Okay. So you take the thumb to be in this way, curl the fingers as if you're holding it. It's very simple, okay? The logic is, find where your fingers are going into. What I generally do is, I keep the fingers like this. When I curl my fingers at the top, they are going away from me. So I'm keeping it like this. At the top, they are going away from me. Since it is going away from me, this is which direction according to this problem? North. So at the top, whenever you consider a point at the top, the magnetic field is in the northward direction. So at the bottom, obviously, it will be in the southward direction. That's it. So find the magnetic field due to a conductor at one point. Exactly on the other point, it will be in the opposite direction. So to put it simple, since this point is at the bottom, in which direction is it? It is in the southward direction. கீழே. அது மேல எங்க பாயிண்ட் பண்ணுது? It is above the conductor. But where is this point? Yes, கீழே மட்டும் தான் பார்க்கணும். It will be south northward. Okay. So similarly, if I take a point here, which is considered to be at a distance of 50 centimeter upward, 50 centimeter above this horizontal plane, right? So direction of current is this. So at the top, where are your fingers going? It is going into the plane. So into the plane means this direction. This direction, according to this problem, is north. So magnetic field, I'll call this point as P2. So magnetic field at point 2 is equal to mu naught I divided by 2 pi into A, which will be 2 into 10 power minus 7 into how much is the value of current? It is going to be 10 divided by A is 50 into 10 power minus 2. So this will cancel this 5 times, right? So 10 power minus 2, this will go 10 power minus 5 times. So 2 by 5 is going to be 0.4. So 0.4 into 10 power minus 5 Tesla is going to be the answer. So 0.5 into 10 power minus 5 Tesla is going to be the magnitude, and the direction is going to be it's going to be northward. Okay. So this is the whole problem. Mark this one as important because many of them get confused between the horizontal and the vertical planes. So I hope you could get some clarity, right? You will be able to do it no next time when they ask. Horizontal plane. Horizontal plane la conductor irukku. Vertical plane la points irukku. So in this question, they have taken points in the horizontal plane and in the vertical plane. So horizontal plane la edukumbodhu, you will report the answer either in terms of vertically downward or vertically upward, which I did in the first case. I repeated, conductor is in the horizontal plane. If the points are also in the horizontal plane, direction of magnetic field will be vertically downward or vertically upward. But if the points are in the vertical plane, they will be either in the direction of north or south. Are you able to understand? Right. See, to put it very simple, what do we do in the case of Biot-Savart law? Biot-Savart law, we take the cross product between DL and R. What do? We take the cross product between DL and R. Whenever you take cross product, the resultant is always perpendicular to both the vectors for which you take cross product. That is why, if you see in this problem, the conductor is in this direction. The point is in this direction. So which one is perpendicular to both simultaneously? Either downward or upward. That is what happened in the first case. In the second case, what happened? The conductor was like this and the point is like this. So conductor is in x-axis, point is in the y-axis. So what will be the direction of magnetic field? It will be in z-axis. So positive or negative depends on where the point is. If the point is in the positive y-axis, then the answer is in the negative z-axis. So it varies. So that one alone you need to consider using the right hand thumb rule. I hope it is clear, right? So actually I'll stop with this. Next class, I'll solve some more problems based on this. Okay. Do you want to copy it? You're done copying? Which slide? Previous slide is what? This copy பண்ணுமா? Okay. Those are online. If you have any questions, you can ask, or else we can write them.
I have no doubt, sir.
No doubt, sir.
Then we'll wind up.
Thank you, sir.
Sir, happy Guru Purnima, sir.
Yeah, thank you, Ma.
Thank you, sir.
Done, madam?